Hi everyone, I have a update here on the resonance, and what we have here is a circuit that was designed by username Ground Loop, and Ground Loop is a member of the Over Unity forum, and he was so kind to do this for me. And this circuit is basically reproducing what a double pole double throw relay does. So I'm capable of putting in a input of voltage input, and this array of MOSFETs are capable of switching, doing the same kind of work. So there would be my two leads coming in, and these here would be my two leads coming out, so doing the same kind of work. This circuit has a small processor there that takes care of doing all the switching of the transistors, and it's being triggered at the frequency I want. What I do is I just attach my signal generator. I'm using this probe here to do that, so it's on the output of the signal generator. But the signal generator is only used to trigger the frequency I want in that processor. It's not powering the circuit like I had before earlier. So right now what's powering the circuit is this 12 volt battery here, and I have the circuit at this time in resonance, and the circuit is an LC circuit with a capacitor. There's my small capacitor that is in series with my inductor, and there's the inductor that I used earlier as well in test 2. And there's a small ferrite core right inside there, and it's loose. It's not filling up the cavity. And let's see here. So what I have it capable of doing at this time, this particular little coil at resonance, it's capable of lighting a fluorescent bulb. So this fluorescent bulb now is lit, and I'll show you if I disconnect the, I'll use the black lead negative here. So if I disconnect the black connection from the battery there, the bulb's out, and there's turned on again, off, on. Alright, I'll connect it back. What I did as well is to demonstrate that the circuit is barely using any power. What I did is I put a LED in series on the positive side here of the battery. So the power is coming through this LED and feeding the circuit. Now the power that's feeding this power is feeding both the solid state processor here, okay, so all the switching work is being taken from here, and obviously the coil switching, okay, at the frequency, and that's just lighting the LED to actually full brightness. I tried it with a really small bulb. I have this really tiny bulb here, and using this bulb you would see it, you wouldn't see there would be no light, absolutely no light coming out of it. It wouldn't even glow. So I just tried to find something that would be able to display the amount of energy that it would take, and that's when I thought of using an LED. So it's very small amount of power consumption. I can't use my meter on that. Using a DC milliamp meter would not be the way to go, and I'll show you why. So there's the bulb lit, and what I'll do too is I'll stop the camera and I'll just hook up this tiny little battery. This is a 12-volt battery. It's a A23 battery, and I picked these up at the dollar store, I think for like 2 for $1 or 1 for $1, I forget. So this battery has 12.2 volts, and it really can't power very much, I mean, but I'll connect it to the circuit and we'll try that and see what it does. So this is my oscilloscope here, a shot. This in the green here is basically the switching of the coil, so back and forth switching of the coil, and now it's at the frequency that it is resonating at. And the this waveform here, which is pretty much perfect sine wave, is my number 2 probe. So the number 1 probe is connected right here. That's picking up a reading in between that LED. And my number 2 probe is just sitting here. It's not connected. It's picking up the radiant energy from this wire that's feeding the light bulb here. So if I just like change the position, see if I back up that little wire there and move it, it's capable of, you know, picking up what's happening there. So here's the information. So in green at first there, that's the measured in between the LED and the what's feeding the circuit and coil. And the yellow is the frequency. I'm using the yellow here, sine wave, to demonstrate the frequency, and I'm using that because if I try to pick up the frequency of the LED, I'm not getting any accurate reading. It's all over the place. So it looks like it's resonating at 17.6 kHz. So what I'll do now is I'll stop the camera and I'll just connect the little battery here so that you can see if it can be powered off that. I never even tried it, but I would say it should work. There should be no reason why. Hang on there. Alright, we're back, and it is successful as I thought it should be. Here's the little tiny battery. There's my finger. That battery is a 12-volt battery, and it has about 12.21 before I connected it to measure it. And as you see, it's leading into feeding the circuit, so it's lighting the bulb. Right? I'll just disconnect the terminal here. You'll see the bulb's off. All right. I'll touch it here. On, off, on, off. It's connected back. So that little tiny battery is feeding the electronics of this circuit. Okay. The pulsing of the coil, and my probe is still here. And I disconnected the LED though to measure the pulses coming from the positive lead here. But as you see, the pickup, I haven't moved this probe here. The pickup is just as good here, and the radiant energy is very strong there. And it's still exactly the same frequency. Alright, so I thought this was kind of cool and interesting, and the fact, you know, that we can light a fluorescent bulb with using just the primary of a coil is also interesting. We don't have to use necessarily the high voltage side. I'll be testing afterwards with a ignition coil and using the primary, trying to get that into resonance, and using the secondary, possibly the way some are, well, we'll be able to do other things with the high voltage of the secondary. And that's about it for now. Thanks for watching, and keep checking for updates. Bye now.